What are some of the most expensive military projects in history? Well, during World War II, Nazi Germany proposed the Atlantic Wall, which is a 200 miles defense running along the Atlantic coast, and it was meant to protect all of occupied Europe from the Allies. It is unclear how much it cost in its entirety, but just the portion that covered France cost about $200 billion adjusted for inflation. Then, there is the more modern American Continental Ballistic Missile System. As a threat of nuclear annihilation from countries like North Korea remains a constant threat, the US have designed missiles to intercept nuclear weapons as they are en route. This defense system approximately have cost $300 billion from the US government. There was also the Manhattan Project, which was a research and development undertaking during World War II that produced the first nuclear weapons. The invention of the atomic bomb led to the bombing of Hiroshima and Nagasaki, and as a result, World War II officially ended in the year 1945. In total, the Manhattan Project cost around $27 billion inflation adjusted. But what if I told you that none of these projects are not even close to the most expensive one? Well, none of these expensive projects come close to the F-35 fighter jet program. The F-35 Joint Strike Fighter is a fifth-generation fighter jet that the Department of Defense started to develop since the late 1990s, and the overall cost of the program exceeds $1 trillion. To learn more about the F-35 project, let's have an expert to give us a basic comprehensive guide of the program.
My name is Mike Sullivan. I work at the Government Accountability Office, better known as the GAO. It's an office that works for the legislative branch of the federal government, and essentially we have oversight over the federal budget. So where federal dollars are spent, we probably have people in there looking to make sure they're being spent wisely and efficiently. My particular job is to work on major weapons system acquisition programs for the Department of Defense. And in doing so, I've been working on the Joint Strike Fighter program since it began in 2001. So I'm here to kind of talk about how it started, how the program has evolved, and where it is today. The requirement for the F-35 started in around the 1990s when the Air Force, actually when the Department of Defense realized that it had an aging tactical aircraft fighter fleet. We had F-15s, we had F-16s, A-10s, and the AV-8B Harrier, which is the vertical lift aircraft that you see sometimes. They were all aging, and not only were they aging, but they could no longer keep up with threats that were revolving around the world at the time. So the requirement for the Joint Strike Fighter kind of grew out of that, and it was supposed to replace the F-16, replace the A-10, and it was considered, at the time, it was thought to be the low-end complement to the high-end F-22 and Super Hornet. The department decided that since we needed to overhaul such a large fleet, that the Joint Strike Fighter, F-35, same thing, would be three variants. And it was designed, they thought they could design an aircraft that would be mostly common parts across all three variants, thereby making it less costly. In fact, I think they were talking at the beginning somewhere around 70 or 80% of all the parts would be common, and they'd be able to build it on the same assembly line, and they'd get a lot of economies of scale. So that was the business case that they set up. They signed a contract to begin development in 2001, and the contract was to produce 2,886 aircraft for $233 billion of total cost. So in 2001, the department began a program to develop and procure 2,886 Joint Strike Fighters across the three variants, different numbers of each. And they had planned to make this available to the three services in the 2010 to 2012 timeframe. And the cost to both develop and procure all those aircraft was estimated at $233 billion. Most expensive acquisition program in the history of the Department of Defense. So they established that business case. That was kind of the financials, the quantities and everything. And on the other side of that, they had requirements that called for an aircraft that would be very, very hard to detect, that would have enough maneuverability to replace F-16s and A-10s to do a ground strike mission, and to be able to defeat threats in the air. A lot of software and high technology kind of capabilities that they wanted on this aircraft.
That sounds pretty good. At fighter planes, that's difficult to detect, maneuverable, and be able to conduct ground strike missions and defeat aircrafts in the air. Well, unfortunately, that's not what happened, because tons of problems actually took place throughout the program.
When they began the program, they had not really done enough what we call systems engineering. That means looking at the requirements and having engineers look and see the feasibility of, for example, having an aircraft that was hard to detect and very, very fast, and at the same time have a very large payload. You know, these things kind of contradict each other, and they hadn't really looked at those things real hard before they signed the contract. So the business case was very optimistic. The cost estimate was an optimistic cost estimate that was made with very little knowledge about what it would take to build the aircraft. So in 2001, they began. In order to make this aircraft do what they wanted it to do, they had numerous new technologies. I remember we counted 8 critical technologies that would have to be on the aircraft that at the time they started weren't mature enough yet to be put into a product development program. So they had that problem. They had immature technologies that they were actually trying to build into a design on the manufacturing floor. That's called concurrency. And that's concurrently trying to invent something while you're trying to actually design it and produce it, manufacture it. That created a lot of problems for getting the design right. So as they moved from 2001 to say 2003, 2004, they hit their first big bump in the road, and that was when they found out that the aircraft they were designing weighed too much, weight is a critical thing for all aircraft, especially fighters. And I think the reasons probably were that they were trying to meet all the capabilities for the aircraft, and when they started putting those into the design, the aircraft grew, the weight grew too much. So they had to stop the program and add a lot of dollars and time at that point and kind of redesign an aircraft that weighed the proper amount. So they had an overweight aircraft, it was a big problem, and they had to stop and redesign it. They got that right eventually. As you move through development, then, the technologies are still immature. There's changes coming out of the designing that the engineers are doing, and these engineering changes have to be worked back into the design of the aircraft. That takes more engineers, takes more money, takes more time. So around 2007, they had to stop again and kind of look at where they were, and they added additional money at that time. Cost was growing, mostly development cost was growing at that time. And a lot of it was because of the immature technologies and the trouble getting the design. So then the program moves along. I would say the next big issue with the program would be in the 2010 to 2012 time frame. They literally had to stop the program again and actually review it to see if it was still feasible given the amount of money they had. They made a decision that the aircraft was definitely necessary for our national security. So at that time they stopped again and put additional sums of money into development. They added more time to the development schedule. This had to be flight tested, and it hadn't really started at that point. Or it had started, but not a lot had been done. They had to add test assets and add engineers and all kinds of things. So big lift in the dollars again. Once they had a design that they could now begin to fly the aircraft, we moved into the design phase was done. They more or less stabilized the design. However, now they had to start flight testing that and seeing what shook out of the program and what changes they would have to make to the design. And the flight tests were bringing back data that showed they had to do a lot of tweaking of the design, a lot of changing, a lot of retooling on the manufacturing floor, a lot of new parts, a lot of different parts. Some parts had to be made to weigh less and things like that. So it was major perturbation to the program at that point. That was around 2010, and that was a Nunn-McCurdy breach. So the Nunn-McCurdy breach is a law that Congress set, I don't know, back in the 80s, I believe, that said if a weapon system program like this gets so much over cost, I can't remember what the percentage is, but if it gets way over cost, either in development or in unit costs for procurement, the program had to stop and be recertified. So that's what a Nunn-McCurdy breach is, and it took the department about 2 years to get through that. During that time, they kept trying to manufacture the aircraft. They were getting data from flight testing that said you got to change this, change that. So on the manufacturing floor, the amount of labor hours it was taking to build one aircraft continued to go up. There was a lot of chaos on the floor. They didn't yet have the right parts counts. Were changing tooling and things like that. And so a lot of those things were costly to development. And additional testing was costly to development. So now here we are. It's 2017. The program has been through all of those changes. It's had the technology issues, the design issues, and the manufacturing issues. It's being flight tested now, and it's probably 90% complete in flight testing. So we are getting to the end of it. The hard push now for the aircraft is to get this very complicated software that has to go in the aircraft, get that done and flight tested. That's where it is now. They've already procured a couple of hundred aircraft, so the program is moving along. I think probably it looks like it's going to be a high-performing jet, but the problem is when they set out on a business case back in 2001, as we discussed, they didn't have enough knowledge about what they were trying to accomplish. So if you look at today, those numbers I started with, they wanted to build 2,886 aircraft. That's down to 2,457. So 400 less aircraft. That's not a huge deal, but you know, they wanted more than that. The cost to develop and then procure all the aircraft went from 233 billion to now 379 billion. That's a 70% increase in total cost to acquire this. And the delivery to the services so that they could actually field these and use them was originally supposed to take place in 2010 or 2012. Now they'll be lucky if they get it, if all three services have it operational by 2018. So you see a 6 or 7 year slip to deliveries. That's what happens when you have requirements for a weapon system. They're very complicated and have not been engineered enough before you begin. They needed a lot more knowledge about what it would take to put this aircraft together than they had. And so concurrency between the technologies they needed in the design, and then as you're designing the aircraft and trying to build it, the other big concurrency that we talk about is flight testing. So they began buying aircraft. I believe they began buying aircraft when they only had about less than 5% of the flight testing done. So they were buying aircraft before they knew all of the issues that was going to come out of developmental flight tests, and now they're having to retrofit a lot of those aircraft too, so that's adding to the cost. Okay, to summarize kind of the evolution of this program, obviously they're probably going to get a very good aircraft, probably one of the best aircraft in the world, if not the best. They always do well at finally achieving the capabilities that they want, but they had a business case that was not properly informed. So they started without understanding the technologies that were going to be needed and how they fit into the aircraft. That cascaded to the design work that took place, and they started having quality issues from the design work, and they started having kind of an overflow of engineering drawing changes, design changes, and that leads to problems on the manufacturing floor. So the department has, I think, taken good lessons from this, has rewritten some of their policies at this point, and we're seeing programs now that where, you know, the key thing, it all starts with requirements, and if the requirements are written in a way that engineers understand what it is they're supposed to build and can estimate the cost more reasonably with more knowledge about what it'll cost for labor, material, design, things like that, they will have a more predictable program. And so we see those lessons coming to the fore a little bit more on some of the weapon systems they're building now. And they're trying to use commercial off-the-shelf kind of products where they can. They're trying to use open systems and things like that. They're not there yet. A lot of these programs are inherently risky and will probably always be fairly high risk, but they've learned lessons that can make them a little more predictable. So that the Joint Strike Fighter was a program that they can continue to learn lessons on about product development for many years.